Hello guys, welcome to the third video of array operation, and we will be talking about searching today. What is actually searching? Searching is traversing and finding the element that we have been given is whether present in an array or not. So on the basis of that we have two types of searching, and one is linear search, another is binary search. Linear search is simply searching and using for loop, but in binary search, there is one condition, and that condition is the array must be sorted. Array must be sorted. This is the very important condition for binary search. So let's talk about linear search first. And let us move directly to Eclipse because linear search is simply moving in for loop and finding whether the element is present or not. Okay, we have been given the array as 1, 2, 6, 2, 5, and we have to find the element 21. Okay, so let us write the for loop, and we'll traverse through array A and we'll check if element to search is equals to I, then make we will print element is present, and to make it present we'll make a flag which will be showing that we have found it, so that we can also print that element has not been found, and we'll make flag equals to true. So after, and if we found it, we'll directly break out of the loop, and if flag means that if flag is equals to true, but we wanted the flag to be false, when current element is not present. So this is a simple linear search, and we'll run now, and it is showing that element is not present. Okay, so this is the basic program for linear search, and let's discuss about the time complexity and all. Okay, so the worst case is when the element is not present, right? And we have done this one, and this is the worst case because the element is not present. So what are we doing? We're moving from a for loop, and which is equal to the length of the array. So this is only the time complexity which has been considering, and so time complexity, what will be the time complexity be? We go off we go off n. Okay, and this is the worst case, and the best case is when the element is present at the first index. Okay, so if we will go here and let us 1, so we will print how many times the for loop has been printing. Okay, let us see, and we can find out that for loop has been moving for one time only, but still for your confirmation I will be moving a for loop. Okay, so count plus. So let us run and see. It is been moving for one time only. So what will the time complexity become? We go off 1. So this is basic time complexity of linear search, and this is all about linear search. Now let's talk about binary search. As we have discussed, in binary search, the elements of array must be sorted. Okay, so why it is called binary search and why must be sorted? Let's talk about this thing. Okay, let's move it above and let's write the heading binary search. So let us take an array A and 1, 2, 5, 6, 8, and 9. Let us take this much and one more element we can take 20. Okay, so this is the array. Let's make it a little bit, maximize it. And what we all can see. What we do in binary search is actually we go to the centermost element of the array. So we can see this is 3 and this is the centermost element of the array. And we check whether is it equal to the element we wanted to search. So let us take, we have to search an element 21 only. Okay, so we wanted to search an element 21. So we check that 6 is equal to 21. We check no. So we have divided our list array into two parts, left and right side. And so this is binary. Binary. We are dividing into two parts. So that's why it is called binary. Two. Okay. So this is you can understand from the word binary only. And yeah, if 21 is greater than 6 or not? Yeah, it is greater than 6. It is greater than 6. So we move to this part of the array. But if we have taken 2, which is smaller than 6, then we will move to this part of the array. Okay, so this is actually what is happening. So when we move here, then what we will do, will again go to the middlemost part of the array. So we check 9. Is 9 equal to 21? We're not talking about 2 here. Is 9 equal to 21? No. So we'll again move to the right side of the list. And is 21? Then again we will go here and this is the list and we consider that the list. And is 20 equal to 21? No. So element has not been found. Okay. So this is all. This is what binary search is doing. We divide into again and again. This is kind of recursion problem. Okay. And so let us again take an example. Now let us take. We need to find element 9. Okay. We'll find element 9. Now what we will be doing? We'll go to 6. Is 6 equal to 9? No. So we'll go to the rightmost part of the list. And when we go to rightmost part of the list, then we check the middlemost part, 9. And is 9 equal to 9? Yes, of course, 9 equal to 9. And then we have found the element. So this is binary search. And I hope these two examples are sufficient for your understanding. If you are not able to understand, please go behind and see this video again because this binary search is very, very easy if you get into one point, and if you're not getting it is it is not a big deal because sometimes it's not we get these things all the things in one go only. So if you wanted to go, please go behind video and see once again. I recommend you, if you're not understanding, please go once again and check this video again. Okay, so now let's go to algorithm and flowchart. Sorry, let's talk and go to flowchart, how this is actually working. Okay, so before going to algorithm, there are some keywords you need to know and for making notes, right? I will be writing here, so you can also make notes of this topic. Let's talk about word target. And I will be using in the algorithm, and if you are not able to understand, then you can check these definitions. It is a value being searched. Okay, and then we talk about index. Index is actually the current location and left or right are the indices from which we use to maintain our search space. Mid. What is actually the mid? Mid is the index that we use to apply a condition to determine whether we should go to left or right or right. Okay, so now we have seen the definitions and now let us see them working in our example. This is the example which we took and it may take a unique color. Okay, so what is target? The target is 9. The target is 9 and index is first index is 6. Sorry, index is equals to 2. 0, 1, 2, 3. Sorry, index is 3. So our index is 3 here. When we go here, our index becomes 5. And if we go here, then our index becomes 6. Okay, right and left. So right will be indicating the index, this one, and left will be indicating this index, 2 and 4 respectively. And mid here is where is mid here? Mid here is 3. And sorry, mid is the value and at index 3, which is 6. So these terms I have taken and I hope you have understood. And now let's talk about the algorithm. What is in our algorithm? It will be recursion. You can take it from recursion. You can do it while loop. I will take recursion only. And for that we will take start index, end index, array, and at target. If you wanted to take start or something else, it is your wish. And as I have taken here left and right, so I will take here also left and right only, so that you are able to understand. And okay, now this is the name of our function. Now let us start. If our left is less than equal to right, so what we will do, we'll check out mid, and mid is left plus right minus left. Okay, now you will be asking why we are doing like this and not like this. Left plus right divided by 2. Because in some of the time complexities, this will affect a lesser time complexity and this will take a higher, because sometimes the indexes are very high, very large. So in that cases our solution might not uh, compromise with the time complexity. So we'll always reject this and we'll do this way. Okay, and our A mid is equals to target, then element found. Then we will print element found. And if it doesn't match, or if A mid is greater than target, so we'll make the left as mid minus, sorry, right as mid minus 1, and else we'll do left equals to mid plus 1. Okay, and then we will again call the function return binary left, comma, right, comma, array, comma, target. And this is all. And if this condition is not satisfied, means if this condition is not satisfied, then we will return minus 1. And what is minus 1? That element has not been found. Okay, so this is what is all binary search is all about. Now let us take the use example again and make it work. Just copy that only. Let us copy this part. Let us see if I am able to copy or not. Okay, this is our question now. First, we will make left and right. Left and right index. In the initial stage, our left index will be 0 and right will be array dot length minus 1, because we are traversing from this to this part. And when we have decided, then we will go to the middlemost part. And left is lesser than equal to right. Yeah, this condition is true. Then we will go to mid and we will find the mid and it will become out 6. Okay, so we are finding here 9. Now let us take other. Let us take 2. We will find out 2 now. Okay, and if A is equals to print, no, this is not condition. This condition is not true. And one more thing I want to tell you, else. Else. Otherwise, this condition will be checked every time. Okay, and else if this is A mid is greater than target, no. A is not, sorry, A mid is greater than target. So right will become this one. The left index will become 1. And it is already 1 only. So this is left and this is right. Okay. So this is left and this is right now. And then we will return with this, and left is left is lesser than right. Yeah. Then again we will take out mid. And what will mid come out to be? 2. And mid is 2. Then we will check if this condition is true. Yeah. And this condition is true, the element found will be printed. So this is all about. Okay, there is one flaw. It is not flaw actually. We can write here and we can return the index also. return mid. We need not to print anything, we can return mid directly. Okay, this would be better because it will be returning, then it will go out of the loop and all this function will return the mid value. And this is all about the binary search. Now let us go to our Eclipse. Okay, so I've already printed an array and this is our array, and what we will be doing, we will be finding and element find equals to, let us take it 1. Okay, so we'll make a binary function and static and binary because we have to return the index, right? So we'll take a left and right and target and in array. Okay, so we'll check if left is lesser than or equal to right, then we will go, otherwise we will return -1. After we have checked that left is lesser than or equal to right, we will check that, we'll first find out mid value. Mid will be equal to left plus right minus left divided by 2. GHT. And if a mid equals to target, then we return mid, and if a mid is greater than, okay, let us take is lesser than target, then we will, sorry, not return, we will make right left equals to mid plus 1, else right equals to mid minus 1, and we will return finally left comma right comma target comma, and again I have written wrong spelling. Okay, so now let us call this function, and left will be 0, a dot length -1, target will be element find, and a will be array. Okay, and let us see. Okay, this is showing this, that's fine. The name of function has been wrong, and we will be printing that index a, we will be printing that element only. Okay, so now let us run and see that element has been returned. Okay, let me show you the console, and this one. Okay, now you can see that element has been returned, and this is all about the binary search. And now let us discuss about time complexity. Because its time complexity is a different topic, for that I have to tell you about various things. So we'll catch up this in the next video. And till the time, stay safe, stay home, stay healthy, and I hope you all liked my video. And if you have any type of flaw that you have seen in my video, please comment down below. Thank you for your lending me your ears. Thank you.